All right, here we go. Section 2.14. Why don't you take a second, read over this section here. All right, go for it. All right, so if I want to figure out the even distribution, the number of cups of rice each person gets based on their weight, the first thing I have to do is figure out what's the total. Well, of course, what is the total weight, that they're going to have between all five. So I want to figure out the total, and that's not how you spell total. All right, so let's go ahead, take a second, add up all five of those weights. All right, so I got 880 pounds. Okay, so the reason we're doing this is we're trying to figure out, all right, their proportion to the total number of weight should be the same proportion that they have to the total number of cups that they get. Okay, and what I mean by that, so if I'm looking at Alan, all right, Alan is 297 of the 880 pounds. Well, how many of the 50 cups does he get? Okay, so I can think about it algebraically like I just set up there, or I could just do 297 divided by 880. Okay, 297 divided by 880, and get 0.3375, and then take that number and multiply it by 50. All right, because this is what, like 33.75%. I want 33.75% of that 50 grains of rice to go to Alan. I got 16.87, so I'm going to round that up to 17. I'm going to do the same thing for Becca. 195 over 880. Okay. And then the same thing for Chris. 161 over 880. And then multiply it. And David and Evan. So I want you to do that yourself. Okay. Follow this process. Just divide their weight by the total and then multiply it by a number of cups. And then if you round up, or it's above 0.5, round up. If it's below 0.5, round down. All right, this is what I got. Okay, for Becca, I got 11 cups. For Chris, I got 9. For David, I got 7. And for Evan, I got 6. And I want to double check just to make sure I did this correct. I want to add up 11 plus 9 plus 7 plus 6. I got 50 cups and not any more. Okay, because we only have 50 cups of rice. Let's look at the second part, part B. Wow, that's a great part B. Just kidding, here it is. Using your results, find the ratio. All right, so we want to do cups of rice divided by the weight of the player for each player, and write each as a decimal number. Is this distribution fair? How are we judging fair? So I want to go here, divide the cups of rice. So for Alan, I would do 17 over 297, and then 11 over 195, and 9 over, and so on and so forth. All right, try that. Leave it as a decimal. See what you get. Okay. I'm going to pause it here, and then I will, so you can check your work. Actually, I'm just going to do the first one with you. 17 over 297. Okay, that's all we're doing. 17 divided by 297, and I got 0.057. Okay. All right, so here are all my numbers. As you can see, I would say that these are pretty fair. You could tell the distribution is pretty equal. I mean, this is 0.056, but it's 0.05. It's like 5%. So I think it's pretty fair. I don't know what you guys think. It sounds like you think it's pretty fair too. Okay, let's keep going. All right, so what are we doing today? Today we're talking about setting up proportions. Can you set up proportions in multiple different ways for the same situation? And do you know when to set proportions equal and when to scale or solve a proportion? We're talking a lot about cross multiplication in this. Okay, this is the mathy way. We'll talk about the algebraic way later. Okay, excuse me. All right, so here's our first example. They give us a solution for this one. Go ahead and read this to yourself. Go for it. All right. Yeah, so let's keep going. Yeah. It would probably be helpful if I read the problem again too. All right, so we're talking about number of students in the population with varying degrees. We want, the supposed stratified sample of 250 students is needed. Okay, so we want to set up some proportions here. So, they talk about the students with the AA degree, okay, and setting up proportions of what you need. All right. How do we solve when a fraction is equal to a fraction? We cross multiply. Excuse me. We cross multiply. This is kind of confusing. I just think of it as crisscross applesauce. You know what I mean? Here, crisscross applesauce. All right. I'll go over that work and what I'm talking about when I say that in a later example when we need to. But remember that this is all about setting up proportions. So I take what I have over my total. I always keep totals together. All right. And I always keep what I want together or have. Okay. So we want to stay consistent. All right. I want to stay consistent. That's the biggest thing with proportions and solving proportions from word problems is our consistency. This is going back to our your geometry days a little bit. Okay. Where you solved a lot of proportions in geometry. All right. So holy buckets. A paper company has been reducing the size of its paper towel rolls in an effort to address rising costs by keeping the price the same but providing less of the product. But the company can recoup increasing costs, the increasing costs to manufacture paper towels without customers paying more per roll. Before the size reduction, 138 sheets cost $3. What is the cost per sheet? Okay, well, how do you think we're going to do this? The cost per sheet, guys. I know that there's 138. My style is working. 1 second. Finally, it's working. Okay, so before the reduction to 138, so I want to be consistent here. I want to figure out the cost per one sheet. So I know 138 sheet cost me $3. So I'm going to write the dollar symbol there, just so you understand where I'm going with this. I want to figure out how much money one sheet costs. So I know that one sheet is going to cost. Well, how much money? I don't know how much money it's going to cost. Remember, when we're trying to find an unknown, we use X, so it costs X dollars. So now we have a proportion set up. We have a proportion. We want to solve for X. If I have a fraction equal to a fraction, I want to cross multiply. Look, I told you did this. I said crisscross applesauce. And what do I mean by that? I do 138 times X equals 3 times 1. Okay, obviously, this is just the same thing as 138x equals 3. Okay, well, how do I get rid of that 138? I'm going to divide both sides by 138, divide by 138, and you should get a decimal. What did I get? I cleared that out. I got x to equal 0.0217. Okay. So that's dollars. Okay, well, that's like 2.17 cents. How did I get that? Well, if that's dollars, cents changes out of 100. I can multiply that by 100 to get 2.17 cents. And it makes sense to me that paper towel roll is like one single sheet. Oh, look at I have one here. Like one sheet right here. This little piece of paper towel, this is like half of a paper towel. This is like half of a half. All right, this probably would cost 1 cent, cost 2.7 cents. That makes sense to me because think about how many sheets of paper towels are in any given roll. You know what I mean? So that makes sense to me. I don't know about you. Maybe the volume hasn't been working. I'm going to turn that all the way up for you. Dial it in. The CEO of the company still wants to charge $3 for a roll. How many sheets need to be in this roll to bring the price up to 3 cents per sheet? All right, so let's think about this. They want to charge $3 for a roll. How many sheets need to be in a roll for the price to bring the price up to 3 cents per sheet? So I have one sheet cost me $0.03. I mean, that's what cents is. It's a decimal of a dollar. Okay. I want dollars to stay consistent, so I know that my $3 should be down here. Well, I don't know how many sheets I have, so I can think about this as one sheet. Okay. and I have X number of sheets. I don't know how many it is, all right? So remember, I use a variable for that. It's our unknown. Fraction equal to a fraction. How do you solve a proportion? We cross multiply. Okay, we cross multiply. I have 0.03x equals 3. Divide both sides. Here, I get x equals 100 sheets. I divide both sides by 0.03. Sorry, I should have said that. Okay. Is this a significant difference in the number of sheets? Determine the percent to quantify your. Oh, okay. 1 second. I'm sorry. Phone call, so popular. Is this a significant difference in the number of sheets? Yes, it obviously is. We're comparing 100 to 138 here. Okay, so I would say yes. Determine the percent change to quantify your answer. So remember, we're talking about a percent decrease here. So I want to do 100 over 138. Okay, this is my new number of sheets over the original, and I got 0.72, which is a decrease. Well, how much is this a decrease of? Well, I just do 1 minus 0.72, and I get 28. Or excuse me, 0.28. Okay, so it's a 28% decrease. Okay. So, all right, this is a mathy proportion now. Now we're getting back to algebra. Okay. This is more mathy. All right, this is a straight mathy. Not a whole lot of setting up here. So if I have a proportion, I have a fraction equal to a fraction here. I can cross multiply, crisscross applesauce. So it's -3 times x minus 1. There we go. -3 times x minus 1 equals 5 times x plus 1. Distribute. -3x plus 3 equals 5x plus 5. I'm going to add the 3x, add 3x. So I get 3 equals 8x plus 5, minus 5, 8x equals -2. Okay, then I got 8 times x, so I divide by 8. Divide by 8, x equals -2 over 8, which is, if I reduce that, -1/4. I divide the top and the bottom by 2. Okay? Make sure you always reduce when possible. All right? We're going to do, I want to do at least one more on this, and then we'll come together as a class for the last one. All right? Actually, maybe we'll do this one together. Yeah, let's do this one together. Okay? We're going to do this one together because I want to talk about it. So we'll say number 4 is a class. All right? That's the end. Okay. We'll see you soon.